Now we'll look at the ramp function. And what the ramp function does is it adds a slope. So the unit step function moved you up or down. The ramp function adds a slope. And just plain R of t, so R of t is just that function that's 0 until you get to the origin, and then it has a slope of 1, up 1 over 1. So that's R of t. So 3R of t is 0 until you get to the origin, and then it has a slope of 3. So over 1 up 3, over 1 up 3. So that's 3R of t.
Oh, so basically, it's something like A, B, you hit -2, and you go over 1 up 5.
Yep. So for A, it's 0 until we get to -2.
It's always 0 until you get to the origin.
And until you get to the origin or where you're translated to. And in this one, we've translated, our first spot is at -2. So we go to -2, and then that adds a slope of +5. So it goes over 1 and up 5. 1, 2, 3, 4, 5. And then over 1 up 5. And it would just keep that slope until something else happens. Well, something else on this one happens when we get to 0. So at 0, it says -5R of t. So we need to be careful about this, just like with the unit step function. We didn't go, when we had -4u of t, we didn't go down to -4, we subtracted 4 from where we were. What we do here is we subtract the slope of 5 from the slope we currently have. So we currently have a slope of +5. Well, we're going to subtract 5 from that, which gives us a slope of 0.
Oh, so it doesn't actually go back to
Right.
Unless it is greater.
And then if it's greater, like if it was -10, then that would make it end up having a slope of -5 in all. Okay. So for B, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5. For 10, that's 5, and that's 10. Okay, so it's 0 until I get to -2. And then I have a ramp function with a slope of 5. So over 1, up 5, over 1, up 5. Until my next thing happens. And my next thing happens at 0. But notice I have two things that happen at 0. One of them is I subtract 5 from my slope. So when I subtract 5 from my slope, that gives me my horizontal slope, my 0 slope. But I also have a unit step function of -10. That brings me down 10. That just moves down 10. So I have down 10, and I now have a slope of 0.
Like straight down 10?
Straight down 10, yeah.
Because it's
Unit.
subtracting 5 from the slope.
Well, so this part is subtracting 5 from the slope. That's what makes it horizontal. The straight down 10 is because I had -10u of t. -10u of t just translates down.
Obviously, the t, like it's because it's by itself, it doesn't go left or right.
Oh, right, yes.
Okay.
Yes.
So the -5RT stops the slope,
Right,
and then the straight down sends it.
yes.
Okay.
So, because the only difference between this one and the one above it is this -10 unit step function, which just took this horizontal line and brought it down. Okay, now C is, we have something new. So C, it's, we're not starting at 0. We've always been starting at 0. Well, we're not starting at 0. We're starting at 10 because we just have a 10, plain old 10. So we start at 10 until we get to -2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. So start at 10 until I get to -2. And then at -2, I have a slope of -5. So that's down 5 over 1, and then down 5 over 1, which would bring me to the origin, which is where my next thing happens. So right now, I have a slope of -5, and then I'm going to add a slope of 5. So I add a slope of -5, add a slope of 5, -5 plus 5 is 0. So that just gets me a 0 slope. Okay, now we have the rectangle function, and I'll be honest, the only time I ever see this rectangle function is in this class. Usually you define it with other unit steps or something like that. So the rectangle function, the way it works is this number added to the t, that tells you where your rectangle is going to be, except it's the opposite, just like when we've been translating. So t plus 1, that means -1. That means we're going to have our rectangle at -1. The number in the denominator tells you how wide the rectangle is. So, and the number in front tells us how high it goes. So, I have my rectangle is going to be at -1, and this denominator tells me it has a width of 2. So to have a width of 2, it'll be going from -2 to 0. So that gives me a width of 2. The -1's in the center, and its height is 10. So that's my rectangle. It's 0 until I get to the rectangle, and then I have my rectangle, and then it's 0 again until I get to something else. This something else tells me that at 3, I have another rectangle of width 2. So it's going to be width 2. So that means 1, 2, 3, 4. It'll go from 2 to 4. And its height is -10. So it looks like that.
Wait, you said -3?
If I said -3, I meant to say 3.
Oh.
So it's not 2 to either side, it's like
Total of 2.
total.
Total of 2. And so for E, we have at t equals 1, we have a rectangle of width 2, so that goes from 0 to 2, and it has height 5. So right there, and it's 0 before that. And then at 3, I have a rectangle of width 2. So at 3, so if it's width 2, it goes from 2 to 4, and it has height -5.
Can you go back real quick?
Uh-huh.
Thank you.
All right, so for these, we'll use ramp and step functions. So for A, v1 of t equals, nothing happens until we get to 0. When we get to 0, we have a slope. It goes over 2 and down 4. So that's or down 4 over 2. That's a slope of -2. So that's -2 r of t. And then when I get to 2, I end up with a slope of +2. So to get from a slope of -2 to a slope of +2, I have to add 4. So this will be plus 4r t minus 4. t minus 2, sorry, t minus 2. And then when I get to 4, I level off. So I have to subtract off that slope of 2 that I have. So that's minus 2r t minus 4. All right, so for B,
Wait, can we,
yeah,
for A, I'm just so confused on this negative 2R and then the 4R,
how I got those?
like a negative 2 slope,
Yeah.
but then go back to the origin with the positive 4 slope? Or is that not that?
Is that not what this? Okay, so the negative 2 r of t tells us, and we don't have anything happening before 0. So at 0, we start with a line of slope negative 2. So that's this part right here. And then something else happens at 2. So that's why I have this t minus 2 here.
Oh, so that first term is like the first slope downward?
Yes.
That's negative 2 slope, and then, okay. Oh, never mind, I get it.
Okay, does that make sense
Yeah,
now?
thank
Okay.
you.
Okay, so for this second one, when we get to 0, we have a plus 2 slope. So that's 2r of t. And then when we get to t equals 2, we end up with a horizontal slope, a slope of 0. So we subtract that slope of 2. So minus 2r of t minus 2. And then when we get to 4, we're going to subtract 2 more, because now we need to get down to a slope of negative 2. So that's minus 2r t minus 4. And then when we get to 6, we have to level it back off, because now we're going to be horizontal again. So we were at a slope of minus 2. To level it off, we have to add 2 to that. So plus 2r of t minus 6. Okay, and then our last one. So nothing happens till we get to 0. And we get to 0, we have a slope of 2, so that's 2r of t. And then look at what happens at 2. We don't change our slope at all. We just drop down 8.
So it'd be what? Plus, minus, minus 8?
Minus 8 u of t. U of t minus 2. Because it's happening at 2. Yep. But we didn't change the slope at all, so we don't have to do anything with that until we get to 4. And then at 4, we need to subtract out that slope, because it has a positive slope of plus 2. We need to subtract out, so it'll be minus 2r of t minus 4.
So,
How are
okay.
you? Wait, no, I don't understand. How are you going positive 2 and then subtract 2 again to get a positive slope?
I think you're at the wrong place when you're subtracting that out. So I have a positive 2 slope here up until 2.
Yeah.
Okay, then at 2, I'm not changing the slope at all. I just drop down.
Yeah.
So I still have a slope of plus 2. That's a positive 2 slope.
So, but why is it not just straight then?
Why is it not just straight here?
Yeah, like on B when we had 2 and then it leveled off, we subtracted 2. And I guess I'm just,
Because I didn't change a ramp function here. I never changed the slope.
I know, so I'm thinking out, my logic is, that's, you have a positive 2 slope, you still have that slope even after
That's
the.
the step function, not a slope function. So R and U are.
I know the step function is not changing the slope, is what you're
Right,
saying,
right. So this is plus 2 slope, this is plus 2 slope.
Oh, I am at the wrong part.
Now, when I get to here, that's where I need to change the slope. And that's at 4.
So you don't have to write a function for when it went back up to the origin?
No, because that's built into the ramp function. Once I have a ramp function, it says just keep going.
Oh, because you don't want to, oh, okay, I understand. Okay.
Get right.
I do understand exactly what you're thinking. I know because I was like, well, how does I understand. It's hard to explain, but I understand.